This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount.
Hi, and welcome back to the continuation of our video series dedicated to designing with the Arduino R4 Minima in Altium Designer. In our previous videos, we've laid the foundation for creating schematics and sourcing the components. Today, we enter the next stage, component placement. This crucial step involves arranging the components on your board for optimal functional manufacturability and aesthetics. We'll explore the techniques for strategic component placement, taking into account factors like signal flow, thermal considerations, and overall design efficiency. By the end of this video, you'll have the skills to expertly position components, setting the stage for a successful PCB layout. So now let's get started.
So what we left off in the previous video is setting the designators on the components. Now what we're going to do is how to establish the connections between the components. Wiring components in a schematic document is akin to drawing the roadmap of your circuit. Each wire represents the path that electrical signal will follow, and it's crucial to ensure that this path is logically and efficient. Clear and organized wiring not only makes your schematic easier to understand, but also aids in troubleshooting and feature modifications. In Altium Designer, you can create connections by clicking on a component pins or terminal and then connecting it to appropriate destination, ensuring that your circuit's signal flow is accurately represented. To add wire in Altium Designer Schematic Editor, select the Place and Wire tool from the toolbar. Click on the starting point, typically a pin or terminal of a component, and then click on the ending point, connecting the wire. Altium Designer will automatically create the wire, and you can continue to wire up your components by repeating this process. To finish, right-click anywhere on the schematic sheet. You can also adjust the routing and path of wire by clicking and dragging their segments as needed to create clear and organized connections. To save time and effort, you can use the keyboard shortcut P+W in Altium Designer to access the Place Wire tool without needing to click on the toolbar. Simply press the P key followed by the W key and you'll activate the wire placement mode. This shortcut can significantly speed up the process of wiring components in your schematic, making your design workflow more efficient. Now we're done putting the wire in the components. I also changed the color by red so you can easily identify the wire object in the schematic. Next, let's move on to the net labels. Net labels are essential to clarify the defining electrical connections in your schematic. They act as a signpost, providing names to various nets or connections, making your schematic more organized and easier to understand. When placing net labels, consider putting them at key connection point where multiple wires converge or split. This simplifies your schematic by representing one electrical net with a single label, even if it connects to multiple components. Net labels are especially valuable when working with complex design or projects with numerous connections. To add a net label, select the Place menu, then Net Label. Click on the wire or junction point where you want to add a label. Press Tab on your keyboard to access the properties in where you can enter the net name. Once confirmed, click the Pause button. The net label will be placed at the chosen location, clearly identifying the electrical connection. Now these are the net labels in each circuitry. Next, we need to add a power port. Power ports plays a pivotal role in schematic design as they serve as the entry and exit points for electrical power within your circuit. They are represented symbolically with easily recognizable icons like triangles or symbols. Power ports establish global connections, meaning that all components linked to the same power port share the same electrical net. This ensures consistent and organized power distribution throughout your schematic. Often, power ports are labeled with their voltage values, example 5 volts, VCC, and ground, for clarity and understanding the circuit's power flow. To add the power port, click again on Place, then click on Power Port. Now snap it to the components or connections that is required. You can access the properties by pressing the tab on your keyboard. This is where you can set the name of your power port and the style of your power port. Then click on the pause button, then left click on your mouse to end the command.
Next is placing a no-connect directives. Placing no-connect directives in your schematic is a useful practice to signal that a particular pin or component terminal should remain unconnected. This is often done to avoid accidental connections or to represent unused pins on components. It helps prevent unintended electrical connections in your design, ensuring accuracy and clarity in your schematic. To place a no-connect directive, click on Place, then Directives, then choose Generic No ERC. Snap it to the pin of the component that needs to remain unconnected. Now we are completed the schematic creation for the Arduino R4 Minima. Before we conclude, let's take a moment to review each circuitry and ensure everything is in order. This thorough examination ensured that our design is precise, organized, and ready for the next phase. So let's dive back into the circuits one more time to ensure a flawless foundation for our PCB layout. The final step in schematic design is compiling it. It checks for errors and verifies component connections. This crucial process ensures that your design is error-free and ready for the next phase of PCB layout, where your schematic will be transformed into physical circuit board. To compile and validate the schematic created, go to Projects panel. Right-click to the project PCB file and click on Validate. To check the results, go to Message panel. Make sure that the compile successful has no error found. And now we can proceed with the component placement. Before proceeding with component placement and PCB layout, it's essential to have a PCB document in Altium Designer. This PCB document will serve as the canvas for translating your schematic into a physical circuit board. It's where you'll arrange components, define the board shape, and route traces. So to create a PCB document, click on File, New, then PCB. After the PCB doc has appeared, save the PCB doc. Right-click on the PCB doc in the project panel, then click Save. The dialog box will appear where you can set the directory of the document and where you want to save it. Just rename it, and here you can change the file name. Now that we have our PCB document in place, the next crucial step is to perform an engineering change order or ECO. ECO is the process of implementing design changes or updates in your PCB layout, ensuring that it aligns with the schematic and design requirements. This process guarantees that your final PCB design accurately reflects your schematic, laying the foundation for a successful and error-free printed circuit board. To initiate the ECO, go back again to Schematic Doc. Then click on Design, then click Update PCB Document. Now the Engineering Change Order dialog box will appear and it will show the components, nets, and classes that will add to your PCB. Next, click on the Execute Changes. Close the dialog box, and as you can see, these are the components that are added on your PCB. So we will stop here in the component placement. In our next video, we will continue the exciting phase of component placement and embark on the journey of PCB layout. This is where your design truly takes shape and the Arduino R4 Minima comes to life. So stay tuned to the next video as we delve deeper into this fascinating process.